Circle with radius 1. And the important values that we talk about on the unit circle, I mean, technically there are an infinite number of points on a circle, right? We are going to talk about 16 of them. And these 16 coordinates that are on the unit circle, they come from our special right triangles. Okay? So what I'm going to do is I'm going to give you a pink triangle and a blue triangle. What do you think these are? Our special right triangles. Okay? And we're going to use these to help us figure out the coordinates on our unit circle. Okay? Our radius is 1. If I'm going to use these triangles to help us, then we want our hypotenuse to be length 1. This is why I had to do that for a warm-up. Okay? So in order for these to be helpful, we want a hypotenuse of 1 because it's going to match up with our radius. Okay? So when I give you these triangles, we've already figured out what the legs would be if our special right triangle had hypotenuses of 1. So on both sides of your triangle, please label the hypotenuse as 1 and then what we figured out the sides to be. Okay? Label both sides of your triangle. Remember, in your pink triangle, the short side is across from 30 degrees. Raise your hand if you need more time on your triangles. Okay. So we are going to begin by labeling what we call the quadrantal angles. Those are the angles that are on the axes. Okay? So, how many degrees is right here? 0. And in radians? Okay. Here. 90 degrees or pi over 2 radians. Okay. Over here, 180 degrees or pi radians. Negative y-axis, we have 270 degrees or 3 pi over 2. And then a full rotation would be 360 degrees or 2 pi. Now, if this is a unit circle with the center at the origin means 0, 0, right? Unit circle, radius is length 1. What's this coordinate right here? 1, 0. Okay? Here's the origin. What is this coordinate up here? Oh, whoops, I just wrote it backwards. 0, 1. Okay? How about over here? What is this coordinate? Negative 1, 0, and then down here. Okay? When you have your reoccurring unit circle quizzes, I would fill in those 4 first. Those are the easy ones. Okay? All right. Let's start with our blue triangles. Okay? Our blue triangles have a 45 degree angles. Okay? We want our hypotenuse to be along the radius. Okay, so it's going to sit like this, where your right angle is going to sit on your x-axis. Okay, our angles are always measured from the x-axis. Okay, so we have 45 degrees. What's 45 degrees converted to radians? Pi over 4. Thank you. Okay, so this is what we're going to do. We're going to follow along. We get our xy coordinates from, we move x horizontal and y vertical. So if I put this triangle on here, we move to the right along the bottom, square root of 2 over 2, and we move vertically up along the side, square root of 2 over 2. So that coordinate, based on our triangle, over radical 2, up radical 2 over 2, excuse me, there's our coordinate. Okay. Now, in the second quadrant, we are 45 degrees away from 180. How much is that? Say it louder. 135. Okay? Think of this. We are pi over 4 away from 1 pi. Three pi over 4. Okay? We are 1/4 pi away from 1 pi. 3 pi over 4. Okay? So same thing. If we set our triangle here with our 45 degree angle and our hypotenuse is along the radius, we would move horizontally along the bottom, but to the left is what we're moving. So we would say our x-coordinate is negative radical 2 over 2. And then vertically we move up radical 2 over 2. Do you think there's going to be some patterns that happen here since we're using the same triangle to create multiple coordinates? I bet so. I bet so. All right, so let's move to the third quadrant. We are now 45 degrees past 180. What would that be? 225. Okay, convert to radians. We are pi over 4 past 1 pi. 5 pi over 4. Pay attention to how I'm saying it. I'm trying to give you some hints on how to remember these a little bit easier. Okay, we're all based on the same triangle, 45 degrees and 1 pi over 4. All right, so if we place our triangle here, with our radius and hypotenuse matching up, we would have to move horizontally left radical 2 over 2 and vertically down along the side radical 2 over 2. So our coordinate would be negative radical 2 over 2, negative radical 2 over 2. Remember, angles are always measured from the x-axis, never from the y. So for our last one, if we place this triangle, we're now 45 degrees away from 360. 315. Okay. In radians, we are pi over 4 away from 2 pi. 1/4 pi away from 2 pi. 7 pi over 4. Okay. And since we're in the fourth quadrant, when we place our triangle, we're going to have to go right along this side and then down. So horizontally, we're moving in the positive direction, but vertically, we're moving in the negative direction along those two sides. Okay. All right, what do you notice about all four of those coordinates? Well, they all have radical 2 over 2 for x and y. It just, when in each quadrant, the negatives and positives change based on where you are in the coordinate plane. Okay? It's kind of boring. It's all the same number. Let's get our pink triangles out, where at least the sides are different. Okay? We will start with 30 degrees. And I'll do all of my 30-degree angles in red. Okay? So 30 degrees is what in radians? Pi over 6. Okay? By next week, that needs to be automatic for you. 30 degrees is pi over 6. 30 degrees, pi over 6. Okay? So if you place your triangle here with the hypotenuse along the radius, and you have your right angle sitting on the x-axis, okay? Look at this. We would have to travel horizontally along that side that says radical 3 over 2, and then vertically along the side that says 1/2. So we're traveling horizontally radical 3 over 2, and then vertically 1/2. So the coordinate, we had to travel to get there, over radical 3 over 2, up 1/2. We're doing this very slowly so you understand where these numbers are coming from. I'm not just pulling them out of thin air. Okay. In the second quadrant, if we were to place our 30-degree angle right there, we're 30 degrees away from 180. 150 degrees. Okay. Convert to radians. We are pi over 6 away from 1 pi. 5 pi over 6. Okay. So when we have our triangle placed here, we would have to move horizontally to the left along this long side, radical 3 over 2. And then we would have to move vertically along this short side, 1/2. But we moved left and then up, so our coordinate would have the negative with the x value. In the third quadrant, we're 30 degrees past 180. Or, in radians, we're pi over 6 past 1 pi. 7 pi over 6. Okay. Some of you probably already have this filled in. You're seeing the pattern, and that's good. Okay? I don't have a problem with that. When we have our triangle here, we would move horizontally to the left from the origin along our long leg and vertically in the negative direction, down along the short leg. So we have negative radical 3 over 2, negative 1/2. Okay. Then in our fourth quadrant, when we place our triangle there, we are 30 degrees away from 360. 330. Okay. Translate to radians here. We are pi over 6 away from 2 pi. (11 pi over 6). 2 pi is 12 pi over 6. Knock 1 off. 11 pi over 6. Okay. And if we follow our triangle, we would move to the right, radical 3 over 2, and then down the short side 1/2. Okay. What do you notice about all 4 of those angles in red? Are their x's and y's the same, with the only difference being the negative and positive? Okay. All 4 of those angles have what we call a reference angle of 30 degrees. They are all 30 degrees away from the x-axis. They are all pi over 6 away from the x-axis. Okay? We have some symmetry going on here. Do you think that pattern's going to continue?
Yes.
Yeah. Okay? (60 degrees is how many radians? Pi over 3. Do you see how, like, the 3 and the 6 like to go together? Okay. They're buddies. Yes. Okay. So is 1/2 and radical 3 over 2. They're buddies. Okay. So if we place the 60-degree angle at the origin with our hypotenuse along the radius, because it's 1, and we have this right angle here. My projector is kind of distorted, so I'm trying to squeeze this in the best that I can. We would travel horizontally 1/2 and then vertically radical 3 over 2. When we place this here, we're 60 degrees away from 180. 120. If you're not doing these calculations in your head when I'm asking for them, you're not doing yourself any favors for learning the pattern. Okay? Pi over 3 away from 1 pi. 2 pi over 3. 1 pi is 3 pi over 3. Knock 1 off. Okay? All right. When we place our triangle here, we would have to travel left 1/2 and up radical 3 over 2. Okay? In the third quadrant, we are 60 degrees past 180. To what? 240. Pi over 3 past 1 pi. Okay. We would have to travel left 1/2 and down radical 3 over 2. Okay. So I think even without this triangle, we all can see the pattern that this last coordinate left, since it's a 60-degree reference angle, is going to have a 1/2 for x and radical 3 over 2 for y. But since we're in the fourth quadrant, we know that the y would need to be negative. Okay? Now, if we're talking about 60 degrees away from 360, that's a nice one, right? 300. I drew a 0. See, there it is. There it is. It just was a little slow. And then pi over 3 away from 2 pi. 5 pi over 3. Okay, so let's look at the patterns. Do you see how the first quadrant is a mirror of the second quadrant? And the second quadrant is a mirror of the third quadrant, and the third quadrant is a mirror. You see how those are all like reflected, as at least with the colors, right? So all of the red angles have the same x, y value, except the negatives and positives change, right? All of the blue angles have same x and y, but the negatives change. All of the green angles, okay? So if you know these three coordinates right here, you can mirror image for each quadrant to know the rest, okay? Any 30-degree angle, so 30, 150, 210, 330, those are always going to have an x value of radical 3 over 2. You just have to think about whether it's positive or negative based on the quadrant. Okay? Now, what does this do for us? Why do I have you know this? Okay? Well, maybe I should do this in black. Okay? Ooh, how about a different color? Any x coordinate is going to represent the cosine of that angle, and any y coordinate is going to represent the sine of that angle. Do you notice how those are in alphabetical order? X, y, cosine, sine. Okay. So if I were to ask you, what is the sine of 150 degrees? You could say, well, the y coordinate's 1/2, so the sine of 150 degrees is 1/2. If I ask you for the cosine of 270 degrees, okay, well, I know that the x coordinate is 0, so the cosine of 270 degrees is 0. Okay, that gives us a lot to work with, doesn't it? Right? We also know what the tangent is from this. It's not x over. Oh my gosh. Try it. It is y over x. Okay. From the unit circle, with these 16 coordinates, we can identify really all 6 of the trig functions. Right? Because if you can identify these 3, what do you do to get the other 3? Flip them, right? Okay. So if I ask you for the tangent of pi over 4, right, you would take the x coordinate, radical 2 over 2, divided by the y coordinate, radical 2 over 2, divided by the x coordinate, radical 2 over 2. What is that? Isn't radical 2 over 2 divided by radical 2 over 2, 1? Ah, that's nice, right? Okay. Let me tell you about a trick that you probably already know. Do you notice how everything is positive in the first quadrant? All of our trig functions are positive in the first quadrant. All of them. Okay. Now, in the second quadrant, which coordinate is positive? The y coordinate, right? And y is associated with sine. So of the 3 major trig functions, the sine is the only one that will be positive in the second quadrant because the x value is negative, so cosine's negative, which is going to make y divided by x also negative. Yeah, you know where I'm going with this. Okay, now in the third quadrant, both x and y coordinates are negative. So both sine and cosine will be negative, but what does that mean about tangent? That ratio is going to be positive. So in the third quadrant, tangent's always positive. Okay? And then in the fourth quadrant, you'll notice that our x coordinates are positive, which is associated with cosine. Now our sine values are going to be negative because the y-coordinates are negative. And since cosine's positive, sine's negative, our tangent ratio will also be negative. So you've seen this ASTC before, haven't you? Okay. Some of you may remember it as all students take calculus. That's how we advertise. Okay. You can remember it any way you want. But I know this has been very helpful for students to remember who's positive, who's negative, in which quadrant. Okay. So let me be very straightforward with you. This is not something that you are going to write down every time you take a quiz or a test. Okay? I'm going to quiz you over the unit circle over and over. Like I have a bunch of blank unit circles that I'm going to give you for you to write out. Because I want you to have like a visual picture in your head so that when I ask you for the sine of 5 pi over 4, you know it without having to write anything down. Okay? If you maybe need to write down like these 3 coordinates to keep them straight at the top of your paper, I could see that being something some of us may need to do. But what I don't want is for you to draw, like, I don't want you to take 5 minutes out of your test to draw an entire unit circle, okay? I really don't want you to have to take 2 minutes out of your test to draw special right triangles. I want you to remember these relationships, okay? So let's talk about kind of how we would use this unit circle a little bit. Let me change my color here. Do like orange. Does that sound good? Okay. So if I asked you to evaluate the trig functions at theta equals, we'll talk about 5 pi over 6. Okay. So 5 pi over 6 is right here. Do you see it? Okay. So the sine of theta, well, let's just write 5 pi over 6. So the sine, oh, darn it. That is not what I wanted, but I bet we can do it. There we go. The sine of 5 pi over 6, what is it? It would be 1/2. That's the y-coordinate. What would the cosine be? Negative radical 3 over 2. That's the x-coordinate. Okay, now here's the fun one, the tangent. The tangent is going to be the y-coordinate divided by the x-coordinate. Okay, we have a fraction divided by a fraction. Let's be smart about this. Okay, fraction divided by fraction. These 2's cancel out. And we have 1 over radical 3. Do I like that? No, we would have to rationalize it to radical 3 over 3. Okay, but guess what? All of those pi over 6 angles have the same xy coordinate, just the negatives are different. So by us doing this, we also know that the tangent of 7 pi over 6 would be a positive radical 3 over 3. And the tangent of 11 pi over 6 would be a negative radical 3 over 3. Okay, we don't have to do that math over and over. Okay? All right, we'll move to cosecant. Cosecant of 5 pi over 6. 2, because it's the reciprocal of 1/2. All right, the secant of 5 pi over 6. So first of all, it'd be negative, right? If we flip this, we have 2 over radical 3. But then we would have to rationalize, right? Okay. And then the cotangent. You can do one of 2 things. You can take the reciprocal of tangent, or you could take x divided by y. No matter how you slice it, we get negative radical 3. Okay. Let's do one of those quadrantal angles. color that would stand out?
Bright green.
It's bright green right there. We'll try it. Hopefully we can see it. Aquamarine. You be able to see that?
Yep. So wide.
That's good. Nah, I can't do that.
We need it like the rest of
What purple?
There's really not a bright pink. We'll try that. It doesn't really matter. Okay. So what's the sign of pi over 2? Here's pi over 2. Our coordinate is 0, 1. What's the sign of it? 1. What's the cosine?
0.
What's the tangent?
Undefined.
The tangent would be 1 divided by 0. We can't divide by 0, can we? Ugh. So it would be undefined. Not ever, Max. Not ever. Okay? What about the cosecant? The reciprocal of sine, so 1. The secant. Okay, the reciprocal of 0, reciprocal means 1 over. What's the reciprocal of 0? 1 over 0, undefined. Okay, however, the cotangent would be 0. Because the cotangent would be x divided by y, because it's the reciprocal of tangent, and x divided by y is okay in that coordinate. All right, what do you think so far? Okay, now, how many of you like silly little tricks to remember things? Okay, I'm going to teach you a trick with your hand to help you remember some of the coordinates.
Like the multiples of 9.
Kind of like the multiples of 9, yes. You can ignore me or you can listen. If it's confusing for you, just wipe it away from your memory, okay? If you know these 3 coordinates, do you know the rest? Yes, because it's all mirrors of each other, right? And really, if you know this coordinate, don't you know that one? Right? There's 3 numbers you got to remember. You just need to know where they go. So if you take your hand, each of these go with an angle, right? Here's 0, here's 90. If we go to 30 degrees, you see this 3 right here? Our x-coordinate is square root of 3 over 2. Go to 45. Square root of, how many fingers are there? 2 over 2. Go to the next finger. Here's 60 degrees. How many fingers are up there? 1. Square root of 1 over 2. How many fingers are down below?
3.
Oh, square root of 3 over 2 for y. Okay, so let's go back to 30 degrees. X is square root of 3 over 2. Y is square root of 1 over 2. 45 degrees. Square root of 2 over 2 for x. Square root of 2 over 2 for y. I can't really do that one very well. Okay? 60 degrees. Square root of 1 over 2 for x. Square root of 3 over 2 for y. Okay? So I'm going to see you. That's okay. I don't care. All right? If it doesn't help you, that's fine. But if it helps, I find people mixing these 2 coordinates up sometimes. And if you mix those 2 coordinates up, you mix these 2 and these 2 and these 2, and then half of your unit circle is wrong. You know what I mean? Okay, so this is what's going to happen. Your homework is going to be this right here. I give you an angle, you tell me all the trig functions of it. But good news, you don't have to draw any triangles. You need to just look at your unit circle. Now, tomorrow we're going to do some practice with it, and you'll have a quiz. But on Monday, by Monday, you know this unit circle without having to look at it. Okay. Okay, so this is what I want you